Namaste students, welcome back to Rama Teaches You. Today we're going to do the second video on class 11th maths, linear inequalities, the English video. Okay, so in the previous video we had already discussed the first topic with us and we were about to do the second topic with questions. Okay, so let's start with the questions. Come on. So Dhruvat, keep a pen and paper with you, okay, so that we can do the questions side by side. Understood? So we are supposed to do this question today. Minus 3 is less than or equal to 4 minus 7x upon 2 is less than or equal to 18. Okay. Minus 3 is less than or equal to 4 minus 7x upon 2. 4 minus 7x upon 2 is less than or equal to 18. Okay. How will we do this? Let's see. So first things first, we have to remove the 4 from both sides. So minus 3 minus 4 is less than or equal to minus 7x upon 2 is less than or equal to 18 minus 4. So this will give you minus 7 is less than or equal to minus 7x upon 2 is less than or equal to 14. Now the minus sign flips all the brackets. So what do we get? 7 is greater than or equal to 7x upon 2 is greater than or equal to 14. Now you multiply all the sides by 2 by 7. 7 into 2 by 7 is greater than or equal to x is greater than or equal to minus 14. 14, when you make it minus 14. No, you don't make it minus. Oh, wait. Yeah. Sorry. Yeah, minus 14. Minus 14 into 2 upon 7. This will give you 2. Okay. 4. Yeah. So 2 is greater than or equal to x is greater than or equal to minus 4. Okay. So this is the final answer. So your answer will be, solution will be minus 4 close brackets to 2 close brackets. Clear? Okay. Next question. Minus 5 minus 15 is less than or equal to, so minus 15 is less than or equal to 3 into x minus 2 upon 5. 3 into x minus 2 upon 5 is less than or equal to 0. Okay, so how will we do this? Again, you multiply all the sides by 5. What do you get? Minus 15 5s are minus 75 is less than or equal to 3 into x minus 2 is less than or equal to 0. So divide by 3, you get what? Minus 25 is less than or equal to x minus 2 is less than or equal to 0. Then you add 2 on both sides, you get minus 23 is less than or equal to x is less than or equal to 2. So the answer will be 2 to 23. Minus 23 to 2. Minus 23 to 2. Clear? No doubts? Easy questions? Yeah. Now, it's going to become very much interesting when we actually go through. Why open brackets, sir? Oh yeah, it is less than, it's not less than or equal to. Okay, so minus 15 is less than. So this will be like this, open brackets. Next question. When inequalities are of the form modulus of ax plus b is greater than or equal to 0. Now, we have to understand what modulus is first. How do we open a modulus sign? If we can learn how to open a modulus sign nicely, then and only then we'll be able to understand the nuances, the extra things that we need to study. So let's actually do this. Now, modulus of a, when I open it, I have two conditions, right? there are two conditions that I have. If a is greater than 0, okay, greater than or equal to 0, modulus of a, when it opens up, it only becomes a. But if a is less than 0, that is if a is negative, then modulus of a becomes minus a. Clear? So this is the rule to open the modulus. Okay, rule to open the modulus. Here, this is how you open up a modulus sign. Now, if you have modulus of x is less than a, okay, when you open it up, what happens? Okay, you get minus a is less than x is less than a. Okay, so basically this is how you look at it. Okay, modulus of x is less than a can be written as, okay, x is less than a or minus x is less than a. Okay, x is less than a or minus x is less than a. And then what happens? This minus x is less than a can be written as x is greater than minus a. Did you understand this? See, if you have modulus of x is less than a, you will write x is less than a or minus x is less than a, which can be further written as x is greater than minus a. So if you use this as 1 and this as 2, what do you get? You get minus a is less than x is less than a. Clear? Now, similarly, if you have modulus of x is greater than a, okay, you will write x is greater than a, minus x is greater than a, or x is less than minus a. Sorry, minus a. Okay, so here what happens? Here, this you the inequality that you will get is what? Minus infinity to a union a to infinity. But here you will get minus a to a. Okay, understood? Now, if there is an equal to sign, what happens? For example, if you have modulus of x is less than or equal to a, then minus a is less than or equal to x is less than or equal to a. Understood? But, and this will give you minus a to a. Both of them are close brackets. But if you have minus a, but if you have modulus of x is greater than or equal to a, then you will have what? X is greater than or equal to a, x is less than or equal to minus a. So you will have minus infinity to minus a union a to infinity. Understood? This is how you open a modulus sign. It's very easy to open a modulus sign. So modulus of z is equal to y. So what will you write? Okay, either z is equal to y or minus z is equal to y. Similarly, if modulus of z is greater than y, so you'll write z is greater than y or z is less than minus y. Understood? This is how you open up a modulus sign. Beautifully, you can open up a modulus sign. Clear, Drupal? Okay, let's actually do some questions in this. Okay, so you have, see, less than or equal to is the easiest. Greater than or equal to, you have to be very careful how to do it. Okay, less than and equal to, it's very simple. So you can say modulus of 3x minus 2 is less than or equal to 1 by 2. So this can be written as C. Modulus of x is less than a, mean less than or equal to a means what? Minus a is less than or equal to x is less than or equal to a. So I can write minus 1 by 2. This can be written as minus 1 by 2 is less than or equal to 3x minus 2 is less than or equal to 1 by 2. So now it's just a simple problem. Opening up the modulus is where a lot of students make silly mistakes. Okay, this can be written as minus 1 by 2 plus 2 is less than or equal to 3x is less than or equal to 1 by 2 plus 2. So this will become minus 1 by 2 plus 4 by 2 is minus 3 by 2 is less than or equal to 3x is less than or equal to 5 by 2. Okay, and then you divide by 3. What do you get? Minus 3 upon 6 is less than or equal to x is less than or equal to 5 upon 6. Clear? So the solution becomes what? Minus 3 upon 6 to 5 upon 6 close brackets. Am I clear? Please tell me if you understand modulus clearly, because there is a 5 marker hidden in this section which is very very important. The one that I told you about yesterday, which actually goes like 2 pages, 2.5 pages solution. Okay, please tell me if you have any doubts. Okay, let's move on to the next one. Now, Drupad, I want you to answer me this. If I have modulus of x is greater than or equal, sorry, modulus of x minus 2 is greater than or equal to 6 means what? Wait, hold on, did I make a mistake here? One second, I think I made a mistake here. Oh, minus 1 by 2 plus 4 is, oh my god, how could I make a mistake like this? Oh no, I'm right. But where did the minus sign go? Oh, yes. I made a mistake. I'm so sorry. So this will become 3 by 2. This will become 3 by 6. And this will become 3 by 6. And this can be further written as is equal to 1 by 2, comma 5 by 6. Okay. Then you have modulus of x minus 2 is greater than or equal to 6. How will you do this? You will have x minus 2 is greater than or equal to 6, or minus of x minus 2 is greater than or equal to 6, or x minus 2 is less than or equal to 6. Okay, so these are the two values. Minus 6. Okay, so from here what will you get? Sorry, from here what will you get? X is greater than or equal to 6 plus 2. X is greater than or equal to 8. From here what you will get? X minus 2 is less than or equal to minus 6. X minus 2 is less than sorry, x is less than or equal to minus 6 plus 2. X is less than or equal to minus 4. Okay, so the solution for us is what? Minus infinity to minus 4 union 8 to infinity. Clear? Okay, next one. So solve, when they say solve graphically, they mean a number line. Okay. Okay, so you have modulus of x minus 1 is less than or equal to 5, and modulus of x is greater than or equal to 2. Now let's do this again. One slowly, we'll do this. Okay, so I can write this as x minus 1 is less than or equal to 5, but it is greater than or equal to minus 5. Am I right? Because it is less than. So, and this can be written as what? X is greater than or equal to 2, or x is less than or equal to minus 2. Okay. So, what do I get here? Minus 5 plus 1 is less than or equal to x is less than or equal to 5 plus 1. Minus 4 is less than or equal to x is less than or equal to 6. This can be written as what? This is already there. So what are the solutions that we have? Okay, the solutions that we have, first and foremost, we'll draw our number line. Okay, a straight number line we will draw. So what are the values that we need to take into consideration? You have the -4, you have the -2, you have the 2, and you have the 6. So my highlighter, see, look at this. One is from -4 to 6. So I will highlight this whole thing. Okay, this is -4 to 6. Now the second highlight I want is -infinity to -2. That is this one, union 2 to infinity. So this is going to -infinity and this is going to infinity. So what are the two areas where you can actually see a highlight happening? Okay, Drupad, look at this. Can you see that this area is being overlapped and this area is being overlapped, right? Only in these two areas you get to see an overlap. So what do? You write the solution to the linear inequality lies in the range -4 to -2 union 2 to 6. Clear? Understood? No, how to, this is the common solution. Okay, if there are no overlaps in either of them, you will say that this inequality has no solution. Understood? If there is an overlap, then it has a solution. If there is no overlap, then you don't have a solution. Next one. Okay, solution of the type, the solution of inequality which contains the terms of the form modulus of x plus minus a and ax plus minus b. Now in this type of situation, I'll teach you how to do it. First things first, put each modulus term equal to 0 to find the corresponding values of x. These values of x are called the critical points. Now Drupad, if it were a linear equation, we would have called it a 0. Okay, if it were a linear equation, we would have called it a 0. But since it's not a linear equation, we will call it critical points. Those points which make the inequality equal to 0 is called a critical point. Okay, so if you have been given modulus of x minus a and modulus of x minus b, then you will put modulus of x minus a is equal to 0 and modulus of x minus b is equal to 0. So what do you get? You get x minus a is equal to 0 and x minus b is equal to 0. Therefore x is equal to a and x is equal to b. They become the what? They become the default zeros of the number line. Okay, now here see, in a number line, like this, if I have two sections, okay, how many parts have I divided this number line into? I have divided into three parts: minus infinity to a to b, and b to infinity. Right? These two critical points or the inequalities of these zeros have divided the whole number line into three parts. Okay, these areas become the range. These areas become what? They become the range. Then what do? After this, divide the whole number line into the disjoint intervals with the help of critical points. If x is equal to a and x is equal to b are the critical points, you will have such a number line. Now Drupad, how do you create a number line? You will always create a number line with this in mind. Okay, the first one from left, when you go to right, you will have both of them are open brackets. Then you have a as close bracket and b has open bracket. And then you have in the third section, you have b as a close bracket and infinity as your open bracket. Always remember this. Okay, open brackets in the left, then one of them will be closed, the other will be open, and again one of them will be closed, the other will be open in these two cases. Okay, so if I were to draw a number line like this, a b c, so how will you write this? You will write this as, this is minus infinity and this is what? Infinity. So what are the intervals that you will have? minus infinity to a, open brackets, then you will have a to b, then you will have b to c, and then you will have c to infinity. Did you see the pattern? Okay, very good. Next. Okay, let's act now. Then what? Consider the intervals obtained in step 2 and solve the given inequality in each interval. And finally, take the union of the solution sets obtained in each of the case. Now, let's actually start with a very simple example. Okay, it will help us a lot. Trust me. Okay, now you have. Let me just write down the question. Modulus of x minus 1 plus modulus of x minus 2 should be greater than or equal to 4. So first things first, what will you do? You will put both the terms inside the modulus equal to 0. So x plus 1 equals 0 and x plus 2 equals 0. So what will you get? Sorry, x minus 1. What am I doing? Yeah. So x will become equal to 1 and x will become equal to 2. Therefore, the critical points are what? 1, 1 comma 2. These are the two critical points that we have. Okay. Now, put a number line here. So, you have 1, 1 and 2. This is infinity, minus infinity, and this is infinity. So the three different intervals will be minus infinity to 1, open brackets, then you will have 1 to 2, open bracket, and then you will have 2 to infinity. So these are the three intervals. Okay, these are the three intervals that we have. Clear? Is it clear up to now? Any doubts, Drupad, here? So we have three intervals. We have to check for each and every single interval. So here comes the first case, case number 1. Okay, in case number 1, what do we get? We have minus infinity to 1. Look at the way I'm writing it, and you have to write it exactly as is. Okay, in case number 1, the region is from minus infinity to 1, right? It is from minus infinity to 1. In minus infinity to 1, if you put a value on x minus 1, this modulus will be negative, right? Any value that I put, both both modulus of x minus 1 and modulus of x minus 2 will become minus of x minus 1 and minus of x minus 2, right? Because they are negative, right? Modulus of x is less than a. If x is negative, then it becomes less. Okay, so what do we get here? We have to put this in this equation. So our original equation is modulus of x minus 1 plus modulus of x minus 2 should be greater than or equal to 4. Therefore, minus of x minus 1 plus minus becomes minus of x minus 2 should be greater than or equal to 4. If I take this minus out, what do I get? Minus of x minus 1 plus x minus 2 should be greater than or equal to 4. And then x minus 1 plus x minus 2 will be less than or equal to minus 4. Okay, so now just open it. X minus 1 plus x minus 2 is less than or equal to minus 4. I take both of them there. I'll get 2x is less than or equal to minus 4 plus 3. 2x is less than or equal to minus 1. X is less than or equal to minus 1 by 2. Okay, So I'll get minus infinity to 1 by 2 minus. Okay, this is for case number 1. Am I clear? Any doubts here? Okay, next one, case 2. When the region is from 1 to 2. From 1 to 2, modulus of x minus 1 will become x minus 1. But modulus of x minus 2 will become minus of x minus 2 because it is negative, right? Now, so what do I do? Again, I use the same formula. I'll put it in this equation. So what do I get? X minus 1 plus minus of x minus 2 should be greater than or equal to 4. X minus 1 minus x plus 2 will be greater than or equal to 4. Okay, so the x gets cancelled, right? Here, this x here and here it gets cancelled. So there is, since the x has already gotten cancelled, there is no solution here. No solution here. Now for case number 3, what do we have? 2 to infinity. So modulus of x minus 1 becomes x minus 1. Modulus of x minus 2 becomes x minus 2. So we'll have x minus 1 plus x minus 2 is greater than or equal to 4. 2x minus 3 is greater than or equal to 4. 2x is greater than or equal to 7. X is greater than or equal to 7 by 2. So you will have 7 by 2 to infinity. Clear? Okay, it will become 7 by 2 to infinity. So the solution set of the inequality, so here you have, now what is going to happen? The solution set is 7 by 2 to infinity. Now combining the inequalities 1 and 2, we get what? Minus infinity to minus 1 by 2 and 7 by 2 to infinity becomes the overall solution. So what happens here? X belongs to minus infinity to minus 1 by 2 union 7 by 2 to infinity. Clear? This becomes the overall solution of the equation. Understood? Okay. Next one. Okay, you and I will both do this together. You will have modulus of x minus 1 upon modulus of x minus 2 is greater than or equal to 0. Okay, so how will we do this? Now there, since there is only one modulus symbol, right? Okay, since only modulus of x is present, we will use x is equal to 0 as our critical point. Right? Modulus of x means what? Only x is equal to 0 is now a critical point. Then we'll draw a number line here. This is 0. Okay. Now, here, what are the intervals that you will have? Minus infinity is here and infinity is here. Tell me, Drupad, how will you write down the intervals? Open brackets, 2, 1. Where is the 1? 0. And the second interval will be close bracket 0 to infinity. Okay, now these are the two intervals for which we have to check. Now for the first interval, case 1, for the first interval minus infinity to 0, modulus of x will become what? Minus x, right? Modulus of x will become minus x. So I can write this equation as what? Minus x minus 1 upon minus x minus 2 should be greater than or equal to 0. This can be further written as minus of x minus 1 upon, sorry, x plus 1 upon minus of x plus 2 should be greater than or equal to 0. This minus minus gets cut off. So you will have x plus 1 upon x plus 2 should be greater than or equal to 0. Now, Drupad, this is where I want you to see and hear, pay full attention, complete attention. Okay. So here what I have, x plus 1 upon x plus 2 should be greater than or equal to 0. So I can write x plus 1 upon x plus 2 into x plus 2 the whole square should be greater than or equal to 0 into x plus 2 the whole square. This and this gets cut off, so we're left with x plus 1 into x plus 2 should be greater than or equal to 0. Now this is only possible if x plus 1 is greater than or equal to 0 and x plus 2 is greater than 0. So Dupat, please listen to this. Okay, you can only have greater than 0 here because x plus 2 is in the denominator. You cannot have equal to 0. This equal to cannot exist here. Understood? Because otherwise the denominator will become 0. Okay, so what are the intervals that we will have? X plus 1 is greater than or equal to 0, which means what? X should be greater than or equal to minus 1. X plus 2 is greater than 0 would mean x should be greater than minus 2. Now let's draw a number line like this. Okay, this is minus 1 and this is minus 2. Okay, so it should be greater than or equal to minus 1 or greater than minus 2. So greater than or equal to minus 1 gives us this whole region. Greater than or equal to minus 2, sorry, minus 2 gives you this whole region. Greater than or equal to minus 1 gives us this whole region. So basically only one region is allowed. Only this region is allowed. So I can write it as closed brackets minus 1 to infinity. This is for the first case, Drupad. Clear? Okay. Next one. If both are negative, what happens if both are negative? Case 2. You have um, yeah, x plus 1. No, 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 this is not case 2. This is part 1. This is going to be part 2. Case 2 is still there. So x plus 1 should be less than or equal to 0 and x plus 2 should be less than 0. So there will be x is less than or equal to minus 1 and x is less than minus 2. So this is minus 1, this is minus 2. So if I use my highlighter and do this, okay, and do this, I can see that only this region is available, and this is where the students make the second careless mistake here, which is there is an less than minus 2. There is less than minus 2, so you will have minus infinity to minus 2. That's it. This will be the second case. Okay, Drupad? Okay, now next comes case number 2. In case 2, what happens? You have to use this region, 0 to infinity. 0 to infinity. Now in 0 to infinity, modulus of x becomes x, right? In 0 to infinity, modulus of x becomes x. So this whole formula can be used as written as x minus 1 upon x minus 2. X minus 1 upon x minus 2 should be greater than or equal to 0, right? Yeah, greater than or equal to 0. I can write it as x minus 1 into x minus 2 should be greater than or equal to 0 by doing all those cut and other stuff. So x minus 1 will be greater than or equal to 0 and x minus 2 will be greater than 0. So I'll get x is greater than or equal to 1, x is greater than 2. Okay, now similarly x minus 1 into x minus 2 is greater than or equal to 0, x minus 1 is less than or equal to 0, and x minus 2 is less than 0. So one case was when both of them are positive, you are getting positive, and when both of them are negative, again you are getting positive. So this will be x is less than or equal to 1, this will be x is less than 2. Okay, now let's actually look at the chart. If x is greater than or equal to 1 and x is greater than 2, from here what will you choose? You will choose 2 to infinity, right? And if you have x is less than or equal to 1 and x is less than 2, here you will choose what? From these two. From these two you will choose minus infinity to 1. Okay? So these are the two regions that you have chosen. So this is a very small question, okay, but this is going to be becoming bigger and bigger and bigger. Okay, so we have done this. Now we have to assess all the regions. Okay, so x belongs to what? Let's see, what are the four solutions that we have, Drupat? You have um so this will become 1, this will become 2, this will become 3, and this will become 4. Okay, so what are the four solutions that we have? You have minus 1 to infinity, sorry, okay, and then uh, you have minus infinity to minus 2, you have 2 to infinity, you have minus infinity to 1. Okay, let's look at let's draw a unique number line like this. Okay, so you have minus infinity on one side, you have infinity on the other, and then you have minus 2, minus 1, 2, and 1 and 2, sorry, 1 and 2. Okay, now let's use the highlighter. So minus 1 to infinity, so this is this region. Okay, minus 1 to infinity including this. Now the second one will be minus infinity to minus 2, not including minus 2. Then you have 2 to infinity. 2 to infinity is this one. Okay, and then you have minus infinity to 1, you have this region. Okay, so how will you write this down, Drupad? Tell me. See, you have these are all regions of solutions. Okay, all of them are regions of solutions. Wait, hold on. Sorry, I made a mistake. I made a mistake. See, the region is minus infinity to 0. When you have minus infinity to 0, then you will not have from minus 1 to infinity. Okay, that's not going to be the case. Okay, x should now see, basically you are going from minus infinity to 0, so you can only go from minus 1 to 0. That's it. Did you understand what I'm trying to say? Minus infinity to minus 2 is still correct. Okay, now the next one is 2 to infinity is also correct. Okay, and this should have been 0 to 1. This should have been 0 to 1. So these four are wrong. I made a mistake. I was making the same mistake when I was teaching the other class also. So this will become minus 1 to 0, and you have 0 to 1. Yeah, and then you have minus infinity to minus 2, and then you have uh, what is the fourth one? Yeah, 2 to infinity. So I have to redraw this. I'm so sorry. I made a mistake here. You when you're choosing intervals, you have to make sure that your solutions lie in that particular interval as well. So you have minus infinity here. You have minus 2, minus 1, 0, 1, 2, and infinity. So you have one region from, I'm just going to draw everything in one color. So you have minus infinity to minus 2, open brackets. Then you have minus 1 to 0, this, and 0 to 1, this, and then you have 2 to infinity. So basically I can write a uniform solution as minus infinity to minus 2, open brackets, min minus 1 to 1, close brackets, and then 2 to infinity. Okay, this is the uniform solution. See, the mistake that I made was, when I choose the case minus infinity to 0, I cannot add up to infinity. I can only go up till 0. And the second interval, when I choose 0 to infinity, I cannot go beyond 0. Okay, I cannot go behind 0 and do all the way up to infinity. That is one thing that you have to take into consideration. Am I clear? Did you understand the mistake that I made? Okay, see, basically, when you had the critical point, okay, when you had the critical point, you had 0. So you basically split the whole number line into two sections: minus infinity to 0, open brackets, and then close brackets, 0 to infinity. So in case 1, you have minus infinity to 0. So your solution also cannot go beyond 0. It cannot even be 0. It cannot go beyond 0 also, and it cannot be 0. Okay, so that is one thing that you have to remember. So minus 2 to 0. Okay, it can only go from minus 1 all the way to 0. But this is correct. There is no problem here. Okay, see, look at this. This is the first solution that we had, right? And so it will go from minus 1 to 0, not minus 1 to infinity, because our interval is only from when to when, minus infinity till 0. It is ending at 0. So your solution for case 1 also should end at 0. Similarly, this is correct. Minus infinity to minus 2 is correct, because it is inside our case interval. Now in the second case, you had 0 to infinity. Okay, so your solutions in that particular case should also lie between 0 and infinity. You cannot have minus infinity or any number beyond 0. You cannot have that. Did you understand this? Okay, let's actually do a couple more questions, and then it will become much more easier for you. Okay, we've done this. Okay, this question. This is also a good one. You have modulus of question x plus 3 plus x upon x plus 2 is greater than 1. Now, there is only one modulus available here, that is x plus 3 is the only modulus. So what will be the critical point, Rupert? Critical point will be what? Minus 3, exactly. Minus 3 becomes the critical point. Okay, so now you have a number line like this. Okay, you have a number line like this where minus 3 is here, and there is minus infinity here, and there is infinity here. So the time intervals will be from minus infinity to minus 3 open brackets, and the next one will be from minus 3 close brackets to infinity. Okay, hold on. We just increase the margin. Okay, much better. Now I have much more space now. Okay, so case 1. Case number 1. What happens in minus infinity to minus 3? Okay, in this interval, what is going to happen? Now, modulus of modulus of x plus 3 becomes what? Minus of x plus 3 in this particular region, right? In this particular region, modulus of x plus 3 becomes minus of x plus 3. Okay, so you put this in the formula. Okay, what do you get? Minus of x plus 3 plus x upon x plus 2 should be greater than 1. Now let's solve it normally. Okay, so you will have minus x minus 3 plus x, and then upon x plus 2 minus 1. So I can write x plus 2 upon x plus 2 here, right? Because I can write this as minus of x plus 3 plus x minus 1 upon x plus 2. So I'm just going to write it like this, should be greater than 0. So this gets cut off. So I'll be left with minus 3 upon x plus 2 minus x minus 2 upon x plus 2 should be greater than 0, which will lead me to minus x minus 5 upon x plus 2 should be greater than 0, which can be written as minus of x minus 5 x plus 5 upon x plus 2 should be greater than 0. Therefore, x plus 5 upon x plus 2 should be less than 0. Am I clear? Any doubts till now? No. Okay, fine. Now, I can also write this as x plus 5 into x plus 2. By multiplying the numerator and the denominator by x plus 2 the whole square, I'll get should be less than 0. Now, to get less than 0, what should I do? X plus 5 should be greater than 0 and x plus 2 should be less than 0, or x plus 5 should be less than 0 and x plus 2 should be greater than 0. Now here, what is the mistake that I made? I made a mistake here. Here x plus 5 can be greater than or equal to 0, because even if the numerator becomes 0, that does not matter. No problem. Okay. Hey, wait. No, there is a less than, it should be less than 0. No. I was correct. So here it should be greater than 0 or less than 0, because why? Because you had a greater than 0 sign. If it had greater than or equal to, then you could have used this equal to sign here, but it is not there, so you will not do that. Okay. So x plus 5 should be greater than 0 and x plus 2 should be less than 0. Okay, let's see. X plus 5 should be greater than 0 and x plus 2 should be less than 0. So x should be greater than 5 and x should be less than 2. So what is the range that we will have? Sorry, x should be greater than minus 5 and x should be less than minus 2. So what is the interval that we have here? Drupad, can you tell me the interval that we will have? Greater than minus 5 and less than minus 2? Open brackets, minus 5 to minus 2. Okay, this is number 1. Next, x plus 5 is less than 0, x plus 5 is less than 0, and x plus 2 is greater than 0. X plus 2 is greater than 0. So what will you get? X is less than minus 5 and x is greater than minus 2. So is there any region like this in the number line where x should be less than minus 5 and it should be greater than minus 2? No, right? There is no overlapping region at all in the number line, so you will say no solution. So this becomes the second one. Now, Gurupad, is this clear till now? Okay. Now, so next step, what do we do? What is the number line that we have? What is the interval that we have taken here? Minus infinity to minus 3. But here what is happening? Our solution is coming out to be minus 5 comma minus 2, right? So what is the modification that I need to make here? Drupad, our timeline interval is between minus infinity to minus 3. But my solution for the first one is coming out to be minus 5 comma minus 2. What is the change that I need to make? Can minus 2 be part of my timeline? See, exactly. So what do I get? Minus 5 to minus 3. Very good. Understood this, right? So this is the, because the interval does not include minus 3. The first interval does not include minus 3, but the second interval does. Case number 2, minus 3 to infinity. Now, from minus 3 to infinity, modulus of x plus 3 will become x plus 3. Okay, so I will write x plus 3 plus x upon x plus 2. X plus 3 plus x upon x plus 2 should be greater than 1. So 2x plus 3 upon x plus 2 should be, minus 1 should be greater than 0, which would give me 2x plus 3 upon x plus 2 minus of x plus 2 upon x plus 2 should be greater than 0. So I'll get 2x plus 3 minus x minus 2 upon x plus 2 should be greater than 0. So this 2 and 2 will get cut off. So I'll be left with x plus 1. X plus 1 upon x plus 2 should be greater than 0. So what are the two cases that I have? Number 1, x plus 1 is greater than 0. X plus 2 is greater than 0. And this will become x should be greater than minus 1. X should be greater than minus 2. Okay. It should be greater than minus 2. It should be greater than minus 1. So here, am I right? Is there any mistake? It feels like you are having a mistake here. Look at this. No, but it's correct, right? Did you understand what I'm trying to do? Okay. Now, x should be greater than minus 1 and x should be greater than minus 2. So, what is the interval that you will have by looking at these two? It should be greater than minus 1, it should be greater than minus 2. So, it should be from minus 1 to infinity, right? Because see, you are saying that you need to see, your dad is telling you that you need to get a score above 90. Your mom is telling you that you need to get a score above 95. So basically the only score that will make both your parents happy will be 96, right? Because if you get 96, then your dad is happy and then your mom is also happy, because both the conditions are fulfilled. So here x is greater than minus 1 and x is greater than minus 2. So you will take minus 1 to infinity to be a part of a solution. And next one, mm, both have to be less than 0, right? The second part, x plus 1 should be less than 0 and x plus 2 should be less than 0. So x should be less than minus 1, x should be less than minus 2. Okay, so who will take precedence here? Drupad, look at this. X should be less than minus 1 and x should be less than minus 2. So what should you get? Yes, minus. No, da. See, your father is saying that you cannot have more than 2 gulab jamuns. Your mother is saying that you cannot have more than 3 gulab jamuns. Okay, so basically, to make both of them happy, you say you only eat 1 gulab jamun. Okay, so it will be from minus infinity to minus 2, right? But our interval is only from where to where? Minus 3 to infinity. So it will be, this will get converted into minus 3 to minus 2. Clear? Understood this? So what are the intervals that we have from the first case? From the first case, we had minus 5 to minus 3. The second case, you had minus 1 to infinity and minus 3 to minus 2. So from this one, these two, we can write it as minus 3 to minus 2 union minus 1 to infinity. Okay, and from case number 1, you have minus 5 to minus 3, minus 5 to minus 3. So minus 5 to minus 3 union minus 3 to minus 2 union minus 1 to infinity becomes your overall answer. Look at this. Wait, where was the question? Yeah, it's almost the same. See, because, see, Drupad, if you look at a number line, even if you write this also, it's correct only. You have minus 5 here, you have minus 3 here, you have minus 1 here, minus 2 here, okay, minus 2 here, and then you have minus 1 here, and then you have infinity here. Okay, so the interval is from where to where? You are having one interval here, minus 5 to minus 3, this one. Then you are having minus 3 included to minus 2 here, and then you are having minus 1 to infinity. So can you merge these two, Drupad? Because in this time, in see, in this interval, minus 3 was not included, but minus 3 is included here. Okay, so can you combine them and write it as minus 5 to minus 2? If you get it, let me know. If you didn't get it, I'll explain again. See, in the first interval, minus 5 to minus 3 was not included. But in the second interval, minus 3 to minus 2, this minus 3 is included again. And then what do? You say minus 5 to minus 3 is my overall region. Union minus 1 to infinity. Understood? Okay, let's do some more questions in this. Okay, this is the, like, basically, if you know how to do this, this is a 5 marker easily. Okay, it's a 5 marker. Okay, Drupad, I want you to try and do question number 3, part 8. So the next topic that we are going to do is application of linear inequalities in one variable. Okay, I told you, no, we are only going to discuss about one variable when I began this chapter. Okay, here also we are going to do only one variable type of questions. Now let's look at the first question. Ram needs a minimum of 360 marks in four tests in mathematics course to obtain an A grade. If his first three tests he scored 88, 96, and 79, 88, 96, and 79, what should his score be in the fourth test so that he can make an A grade? Okay, Rupert, we know that A grade, for an A grade, what you should have, a minimum of 360 marks should be needed. So let us assume he gets X marks in the fourth test. Okay, so what will he get? 88 plus 96 plus 79 plus x should be greater than or equal to 360 degrees. Sorry, 360 degrees, not 360 degrees. Should be greater than 360 for him to get an A grade. So this whole thing adds up to what? It adds up to 9 plus 9, 15 plus 8, 23, 3, 263, right? Yeah, 263. 263 plus x should be greater than or equal to 360. Therefore, x should be greater than or equal to 360 minus 263. X should be greater than or equal to 7, 9. Yeah. So x should be greater than or equal to 97. So he should get, what will be the range of marks that he can get from 97 to all the way to infinity? No, he won't get from 97 all the way to infinity. He will get from 97 to 100 because that is the limit that you can have, right? So some common sense is also required. You cannot write from 97 to infinity. So to receive grade A in a course, one must obtain an average of 90 marks on or more in 5 examinations, each of 100 marks. If Sunita's marks in the first 4 examinations is 87, 92, 94, and 95. Okay, so she has 87, 92, 94, and 95. Then find the minimum marks that she needs to obtain in the fifth exam to get a grade A or above. Grade A should be 90 marks or more. Okay. So plus x upon, we are talking about the average, should be greater than or equal to 90. Okay. Must obtain an average of 90 marks or more. Yeah. Should be greater than or equal to 90. So this whole thing adds up to what? 368 plus x should be greater than or equal to 450. X should be greater than or equal to 450 minus 368. X should be greater than or equal to 268, and yeah, he should get more than or equal to 82. Okay, so her range of marks will be from 82 to 100. Okay, this will be the solution. Next one. In the first 4 examinations, each of marks 100, Mohan got 94, 73, 72, and 84. 94, 73, 72, and 84. If a final average greater than or equal to 80 or less than 90 is needed to obtain a final grade B. So he is looking for a B grade. Okay. So it should be greater than or equal to 80 and less than this B grade 90. Okay. So then what range of marks in the fifth last examination will result if Mohan receives a B grade in the course? Okay, so we have to take the average. 80 is less than or equal to 94 plus 73 plus 72 plus 84 plus x upon 5 is less than 90. Understood? So 18 to 5 are 400 is less than, so 4, 4, 8, 10, 13, 1, 9, 10, 17, 25, 32 plus x is less than 90. Is this correct? 323? Yeah, 323 is correct. Okay, so then I do what? A 400 minus 323 is less than or equal to x is less than 90. 90, oh sorry, 450, not, this will be 450. 450 minus 323. So 400 minus 323 is what? 77 is less than or equal to x is less than 7, 2, 3, 4 होने के लिए 1. So this is the solution that is coming out to you, but common sense dictates that he should get somewhere between 77 should be less than or equal to x should be less than or equal to 100. Okay, that should be the range. So 77 comma 100. Clear? You're also getting the same answer? Okay, next. So next question. The sum of three consecutive integers must not be more than 12. What are the integers? Consecutive integers can be written as what? X plus 1 plus x plus 2 should not be more than 12. More than 12, but it can be equal to 12. Less than or equal to 12. So 3x plus 3 should be less than or equal to 12. 3x should be less than or equal to 9. X should be less than or equal to 3. So the numbers will be what? 3. No, no, no. The numbers will. Yeah, no, 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 no. It's a range, Drupat. It's not equal to minus 3. It's a range. So you can have minus infinity. It's starting from minus infinity, but it goes like this: minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3. So you will get a set of answers. Understood? You have to make sure that all of them are integers. So you write some numbers in front. And then you say that this can go all the way up to minus infinity. Okay. Yeah. So the numbers cannot be 3, 4, 5. Okay. The numbers will, one of the set of numbers will be 3, 4, 5. But that's not the only solution. That's what I'm trying to tell you. Clear? Next. So find all the pair of consecutive even positive integers, both of which are larger. Both find all the pair of consecutive integers or consecutive even positive integers, both of which are larger than 5, such that their sum is less than 23. Okay. Pair of, that means we are looking for two pair of consecutive even positive integers. So how will you write consecutive even positive integers, Drupat? No, no, like in algebraic form. Both of them should be greater than 5. You can write it as x is greater than 5 and x plus 2 will also be greater than 5. Okay, where x is an even number, x belongs to an even number. Okay, and their sum should be less than 23, that is x plus 2 should be less than 23. So 2x plus 2 will be less than 23. 2x will be less than 21, x will be less than 20. Okay, sorry, x should be less than 20 upon 2, x should be less than 10.5. Okay, x should be less than 10.5. Now, what are the numbers that you will have? X should be greater than 5, x should be greater than this thing, less than 10.5. So you can have 6, 8, 8, 10. Okay, 6, 8 and 8, 10. You can also have 10 and 12. No, 10 and 12 will be 22. Yeah, this also is fine. So Drupad, these are the pairs that you can have: 6, 8, 8, 10 and 10, 12. Clear? Because 10 plus 12 is 22. It is still less than 23. Clear? Next one. Yeah, 6, 8, 8, 10 and 10, 12. Next question. Find all the pair of consecutive odd positive integers, both of which are smaller than 10, such that their sum is more than 11. Okay, so find all the pair of consecutive odd positive integers, both of which are smaller than 10. So odd numbers can be written as what? X is less than 10, and if x is an odd number, then you can write x plus 2 is also less than 10. 3 plus 2 is 5, right? So such that their sum is more than 11. X plus 2 should be greater than 11. So 2x plus 2 should be greater than 11. 2x should be greater than 9. X should be greater than 9 upon 2. X should be greater than 4.5. Okay, so what are the odd numbers that are above 4.5? You can have 5, 7, 9. Okay, so what are the pairs that you can have? 5 comma 7, 7 comma 9, 9 comma 11. Clear? Did I make a mistake? It should be less than 10, right? Yeah, but why is 9 not going to come? Yeah, but no, the sum should be more than 11, right? Yeah, the sum is more than 11. 5 plus 7 is 12. 9 plus 11 is 20. The sum is more than 11. X is less than 10. That is correct. X plus 2 is also less than 10. So, yeah, that is also correct. X is less than 8. Uh, oh, yeah. Drupad. See. X should be less than 10. X plus 2 should also be less than 10. Okay, x should be less than 10 and x plus 2 should also be less than 10. So this will lead to what? X should be less than 8. So that is the reason why 9 won't be included. This won't be included because x should also be less than this thing. Clear? Yeah. Okay, next one. Based on profit, cost and revenue. Okay, so Drupad, can you tell me what is the difference between cost and revenue? How is cost, revenue, and profit related to each other? You learned this in 8th class when you were doing this comparing quantities. 8th class. What are the different? What is the how are cost, revenue, and profit related to each other? Just it's common sense, Drupad. Okay, fine. If you forget also, Drupad, you are getting some revenue. So how will these three be related to each other? Yeah, that is fine. I thought you would say revenue minus cost is profit. Okay, fine. Because that's what we are supposed to do here. Because revenue and cost has been given to us. Cost has been given to us and revenue has been given to us. Where X is the number of items sold, produced and sold. How many items must be sold to realize some profit? Okay, some profit means what? The but very important line. Some profit means what? You cannot have revenue minus cost should be greater than zero, not greater than or equal to zero. Because if you say equal to zero, then what happens? It's no profit, no loss. So these are the wordings that you need to take into consideration. Okay, so can you try this one yourself? Find me the answer. So, I'll give you this question as homework. Okay, and the answer to this is x should be greater than 50. Okay, so let's do one thing. Let's continue this in the next class. Okay, uh, so if you do like the videos that I'm posting, if my explanations are very clear to you, please do like, share, and subscribe to my channel. And I'll see you in the next class. Thank you so much, and have a nice day.